Part 1. Why the Stars Are So Quiet. You wake up in the middle of the night in a strange, vast forest. You know instinctively that this forest is teeming with life, including predators, hunters, and prey. But when you hold your breath and listen, you hear absolutely nothing. There is no rustling in the leaves and no animal calls. There is only dead silence. Ask yourself, is the forest empty or are the inhabitants simply staying quiet because they know that in this forest, making a sound means death? When we look up at the stars at night, we are looking into exactly that kind of forest. For decades, we've been asking the same naive question: where is everybody? We're looking for friends. But we never seriously stop to think about why the universe is so damn quiet. Over the next few minutes, I'm going to explain why this silence isn't a coincidence. We're looking into the dark forest theory, which is a terrifyingly logical solution to the Fermi Paradox. The theory suggests we aren't alone. We're just the only ones stupid enough to light a fire and shout hello at the top of our lungs. I'm going to show you why we need to stop doing this immediately if we want to survive as a species. Part 2. The missing evidence of alien life. Let's look at the night sky again. Strictly from a physics perspective, what you see, or rather what you don't see, is a statistical impossibility. Our galaxy, the Milky Way, is a gravitational system of about 100 to 400 billion stars. The latest data from the transit method, where we measure the tiny dip in a star's brightness as a planet passes in front of it, suggests that planet formation is a fundamental part of how stars evolve. Almost every star has a planetary system, while many of these are gas giants in uninhabitable orbits. Even if we filter conservatively, there are still billions of potentially habitable rocky worlds in the Goldilocks zone where water can exist in liquid form. Now let's do the math. Assuming the emergence of life is an extremely rare event that only happens once per billion years per galaxy, given the Milky Way's age of over 13 billion years, we should statistically be living in a galaxy that has already been fully colonized multiple times. We should be finding signatures. I don't mean greetings or radio music, but rather hard thermodynamic traces. A technological civilization consumes energy. According to the second law of thermodynamics, any work performed inevitably generates waste heat. A civilization harnessing the energy of its star, a so-called Type 2 civilization, would turn that star into an infrared radiator. We should be seeing Dyson spheres, which are megastructures that envelop entire stars. We should be measuring spectral anomalies from artificial isotopes in stellar atmospheres, or detecting high-energy neutrino streams from antimatter reactions. But what do we actually measure? We measure nothing. The electromagnetic noise of the universe corresponds exactly to the thermal equilibrium of dead matter. There are no artificial patterns and no order, only chaos. This is the Fermi Paradox in its simplest, most brutal form, representing the massive gap between a mathematical probability of nearly 100% and an empirical observation of 0. For a long time, we interpreted this silence as loneliness. We assumed the great filter that prevents life from flourishing was a biological one, and we thought the jump to complex cells was just extremely unlikely. But there's another solution based on game theory and resource scarcity, namely the dark forest hypothesis. If this hypothesis is correct, then our current habit of broadcasting signals into space isn't scientific progress. Instead, it's a fatal strategic blunder. We are violating the ultimate rule of galactic security. By the way, it's definitely not a mistake to like this video and subscribe if you want to see more like this one. Part 3. The naive ways we revealed our position. To understand the risk, we have to recognize our own historical bias. In the mid-10th century, the rise of radio astronomy sparked a wave of scientific optimism that, looking back, was really just anthropocentric projection. Pioneers like Frank Drake operated under the implicit assumption that technological progress and ethical maturity go hand in hand. The logic was that any species powerful enough to pull off interstellar travel must have moved past its internal aggressions. Otherwise, they would have wiped themselves out with nukes long ago. Therefore, aliens must be peaceful. But that assumption has no scientific basis, as it's just us projecting our own hopes onto unknown biological systems. Based on this unproven hypothesis, we started actively betraying our position. In 1974, we used the Arecibo Observatory to blast a 20-terawatt signal toward the M13 star cluster. We didn't just encode our math and biochemistry. We also sent our exact location in the solar system relative to the sun. Even worse is the data leak from the Voyager probes. They carry a map showing our position relative to 14 pulsars. Pulsars are rapidly rotating neutron stars that emit incredibly precise signals. Since their rotation slows down predictably over millions of years, they act like cosmic clocks. Any civilization that finds this map can triangulate not just where we are, but by comparing the pulsar frequencies exactly when the probe was launched. We've handed an unknown observer three critical pieces of intel, including our spatial vector, our level of technology, and our biochemical makeup. Strategically speaking, we just lit a magnesium flare in a dark, unmapped territory. Part 4: The Cold Logic of Survival in Space. Let's strip away the emotion and look at this axiomatically. The framework of cosmic sociology applies the principles of evolutionary game theory to interstellar distances. The model is built on two premises. First, the primary goal of any civilization is survival. This is an evolutionary tautology. If you don't want to survive, you go extinct and you're no longer part of the game. Second, civilizations grow exponentially, but the resources in their accessible light cone are finite. This inevitably leads to a Malthusian limit. The universe might be infinite, but for any given civilization, there is only a limited amount of reachable stars and matter. Every star, one civilization claims, is one less star available to another. This creates a competitive pressure that has nothing to do with morality. It's not about evil, but about resource management. Another critical factor is the technological explosion. On a cosmic timescale of billions of years, progress isn't linear. The jump from the Stone Age to splitting the atom took only a few thousand years on Earth, which is a blink of an eye compared to the age of the universe. To an outside observer, our current status is irrelevant. A civilization using primitive radio waves today could master physics enough to become an existential threat in just a few centuries. From the perspective of an advanced civilization, there's no such thing as a harmless neighbor. There are only neighbors who aren't dangerous yet. Part 5: The Impossible Game of Interstellar Trust. The biggest hurdle to cooperation is the speed of light. It sets a hard physical limit on communication. Suppose we discover a civilization 100 light years away. A hello takes 100 years to get there, and the reply takes 100 years to get back. A single cycle of dialogue takes 200 years. In that time, that other civilization could make technological leaps we can't even imagine. This leads to the chain of suspicion. We don't know if they're benevolent, even if they are. They don't know if we are. And we know that they can't know if we trust them. Since we can't verify trust through fast communication or treaties, the Nash equilibrium of game theory takes over. In a situation where an enemy attack means total annihilation, which is an infinitely high loss, and a preemptive strike reduces your risk to zero, the only rational move is to strike first. It doesn't matter if the other guy is actually hostile. The mere mathematical probability forces every rational actor into aggression the moment they are discovered. He who hesitates dies. Part 6: Why Advanced Species Stay in the Shadows. An often overlooked point is how physically hard it is to hide. Why is everyone so quiet? According to Landau's principle, information processing is tied to energy consumption. A high-tech civilization running calculations or operating starships generates entropy in the form of heat. To hide a ship from infrared sensors, you'd have to cool it down to the temperature of the cosmic background, which is about 2.7 Kelvin. The problem is you need energy to cool something down, which just creates more heat somewhere else. Thermodynamically, camouflage is incredibly expensive. The larger a civilization gets, the brighter it glows in infrared. This means advanced civilizations have to be extremely paranoid. They know they're glowing thermodynamically. Every extra active signal, like a radio message, spikes the probability of being detected. The silence in the universe is therefore not inactivity. It is the result of extreme discipline to minimize the thermodynamic footprint. Part 7: The Most Efficient Way to Destroy a World. Think about what a preemptive strike would actually look like. If you're picturing massive invasion fleets and laser battles, I hate to break it to you, but that's just not efficient. An advanced actor would use relativistic projectiles. If you accelerate an object to a significant fraction of the speed of light, the laws of special relativity kick in. The mass of the object effectively increases, and its kinetic energy becomes unimaginable. A small projectile that is barely larger than a bullet hitting a planet at 95%, the speed of light releases enough energy on impact to ionize the atmosphere and boil the oceans away. It's not a conquest, but a sterilization. It's cost-effective, fast, and absolutely lethal. Since we've already broadcast our coordinates, an attacker wouldn't even have to enter our solar system. They could just fire from a distance at the exact position we so kindly provided for them. Part 8. How we painted a target on our back. Critics often argue that our everyday TV and radio signals would betray us anyway, but that's physically inaccurate. The signal strength of those transmissions is billions of times higher than our diffuse leakage. We are creating a signal with an incredibly high signal-to-noise ratio. In a universe dominated by chaotic noise, a coherent signal like that is as conspicuous as a laser pointer in a dark movie theater. We've pointed that laser pointer straight into the darkness. Part 9. Why finding nothing is so terrifying. You're probably wondering if this is all just theory. I hate to break it to you, but we have data. The Breakthrough Listen project conducted the most comprehensive scan of the sky ever. We looked for narrowband signals and laser pulses. The result is statistically significant, and it is zero. We haven't found any von Neumann probes, which are self-replicating machines that could theoretically colonize the galaxy in a few million years. We haven't found any Type 3 civilizations. If we analyze this statistically using Bayesian inference, we have to adjust our expectations. Before the search, the probability of loud, friendly aliens might have been at 50%. But with every year we listen into the silence, find nothing, that probability drops drastically. While the probability of the dark forest hypothesis climbs, the absence of evidence becomes evidence of absence. If that's confusing, think of it this way. Imagine you're 50% sure your friend is home. You ring the doorbell, you call his phone, and you knock on the windows, but nobody answers. With every attempt that goes into the void, you have to correct your assumption. It becomes less likely that he's just not hearing you, and more likely that he isn't there at all. Or, and this might be the grimmer reality, he's intentionally keeping quiet. It's the same in space. The longer we listen and hear only silence, the less likely it is that everyone is out there broadcasting happily in a dark forest. The only logical state is stealth. The silence doesn't prove that no one is there. Instead, it proves that the ones who are there have learned to keep their mouth shut. Only young, naive civilizations like us make noise. There's even a more radical theory, namely the berserker hypothesis. It's possible that autonomous, self-replicating probes exist with the sole purpose of detecting and neutralizing technological signatures. Our great silence might just be the brief window before those automated systems react to the signals we've just started sending. Part 10. The best strategy for the human race. To sum it up, the dark forest theory solves the Fermi Paradox without needing any exotic assumptions. It only requires resource scarcity, the speed of light, and thermodynamics. The scientific takeaway suggests we should probably exercise some restraint. Maybe it would be smarter to take a hard look at active me programs instead of blindly charging ahead. We could stick to passive listening in the context of CD and focus on making our detectors more sensitive to faint signatures. Given how many unknowns there are, it's at least worth discussing whether we should keep proactively revealing our position. We are at the very beginning of our technological evolution. We've only just started to realize how dangerous the universe can be. As long as we don't know who or what is lurking in the woods, the only rational strategy is absolute silence. In a dark forest, you don't survive by lighting a fire. You survive by staying invisible. If you enjoyed this video as much as I enjoyed making it, I'd really appreciate it if you use the hype feature to support the channel. See you in the next video.